After months of work, our rain gutter generator is producing nearly a watt of power. But is that enough to charge a smartphone? Checking the specs on this USB charger, we see that the output can be up to 2100 milliamps. But to find what a phone actually uses, let's connect one to a bench power supply. This phone draws anywhere from 500 to 1200 milliamps, which is way too much for our generator. But if we limit the current, we find it can charge on as little as 200 milliamps. But when we divide our generator power in watts by USB voltage, we find we're limited to only 160 milliamps max. Fortunately, this older Samsung phone seems okay charging on just 90 milliamps, which our generator can easily produce. But there's a problem. We've seen our generator make as much as 22 volts, which could easily damage a smartphone. To prevent that, we're going to use something called a buck converter and adjust it so the voltage never gets above 5.5 volts. As a bonus, this one can also limit current, which prevents the phone from drawing more than the alternator can handle. So far, we've tested all the electronics on temporary breadboards, but it's time to make things more permanent. Let's solder the rectifier onto a circuit board, mount everything to a piece of acrylic, and wire it up with screw terminals so it's easier to use. Fastening it to a wooden box with hinges will make it easy to access the back in case we need to adjust anything. Okay, the new charging system is installed, but it's just not raining hard enough to make any power. We started this project back in October, right before the heavy rains, but now we're on the tail end of the rainy season, so we're not getting the heavy rainfall we had back in December and January. But don't worry, I've got an idea. Toilet tanks have special valves that let them flush way faster than they fill. Our gutter isn't very big, but it's over 30 feet long. If we can make it fill with water and flush like a toilet tank, we'll have no problem generating power. I'm starting by gluing plastic pieces around the downspout with little holes to control the flow. A ping pong ball works great to open the valve in the sink, but failed so miserably in the gutter, I'm scrapping the whole thing and starting over. If we're trying to mimic a toilet, why not use toilet parts? Cutting down the rubber flapper from this flush valve makes it just fit in our funnel for the vertical pipe. A PVC end cap provides a nice sealing surface and a place to drill a hole for controlling the flow rate. I glued a food saver bag around the outside of the funnel, which appears to make a watertight seal. This plastic bottle could be great for opening the valve automatically, but we don't know if it's buoyant enough for the job. High school math teaches us to find the area of a circle, but we're rarely told a reason why. Well, finding the area of this valve seat and multiplying by the pressure tells us exactly how much force it will take to open. But will the float be able to open it? The force of the float, known as buoyancy, is defined as the weight of the water displaced. It's easy to calculate, but even easier to fill with water and weigh the darn thing. Luckily, the buoyancy is more than double what is needed for the valve, so we're golden. All that's left to do now is shove the open end of the food saver bag through the downspout, glue it to the gutter, attach the bottle to the chain, and wait for bad weather. Okay, very funny, Mother Nature. We're finally ready to make power, and you send us snow? Ugh, this is painful. Ow! 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 It's hailing, but it hasn't started running yet. It'll go here in a second, I assume. Look at this. I'm losing because of the hail on top of my float. Let the water down, man.
It doesn't soak my phone down there. Look at this. It just packed with hail. Oh.
The weather eventually got back to regular rain, so the setup can do its thing for a while. I pointed a security camera at the valve to keep track of runtime around the clock. Sometimes it goes all day without filling. Other times it runs twice in 20 minutes. When it does cycle, it charges for about 5 minutes, and if I happen to be home, I run out there to check the charge on the phone.
Here we are again. What percent are we at? Show me. 90%. Okay. We're going to keep track of that.
At the end of the cycle, the phone usually flashes the current state of the charge.
Okay, the float just closed. What do we got? Show me the charge. $91! Yes! Did you see that? Okay, it was at 90%, and now it is 91. We are adding power to the phone. We aren't just losing it. It is actually going in there and charging the battery at night in residential Oregon. This is awesome.
Clearly, I was pretty stoked. All that work finally paying off, the gutter filling and emptying on its own, but I started having trouble getting a consistent charge, so I brought everything back inside to do some testing.
Okay, just as a gut check, I've got my special power supply called a Variac, replicating the power output of our alternator, and then I've got our charging circuit set up here, converting it to DC and going straight into our smartphone. And I'm just going to leave it here all night and make sure that it's actually able to charge the phone. Everything looks good, but checking the percentage, this 87% charge, we're just going to let it run and just make sure that it's actually doing something overnight. Okay, it is the next morning. What was it, 7 o'clock? And it was 87% last night. Late last night. Wake up, sucker. Oh! Okay, this is not good. Not good. Okay, so to be able to figure out what's going on inside of this thing, we need to be able to access the battery. And fortunately, this happens to be a phone that has a removable battery. But to figure out what's going on, we need to be able to connect directly to the phone and the battery as they're charging and working. But they tuck the contacts way inside of there so that when it's closed up, you just can't get access to probe them. What to do? What to do?
If we take careful measurements of the battery, we should be able to design something in CAD that when 3D printed, makes it easy to get what we need. Okay, so what we've got is our battery connected to the phone as if it were in there with a wire going between each of the 4 contacts, but we've taken the main power wire, the positive, and we're running it through our multimeter set to amps. So this allows us to see how much current real time is going from the battery to the phone or vice versa if we're charging it. And right now the phone is actually powered on, but the screen is off, but we're still drawing hundreds of milliamps as the phone is doing its various things in the background. And so this is why I've turned the phone off every single time that I've put it on the charger out there, because clearly, especially if it's not raining, the phone is just going to go dead as waiting for the rain to come and charge it. And a lot of times it's pulling more current than we can even offer when we're charging there with the rain generator. So let's turn the thing off and we'll figure out what's going on with the phone in its off state. We've brought our charging setup back and we've got our phone switched off, connected to the battery, and you can see there's nothing going between the battery and the phone right now. So this is just as if we had it out there waiting for the rain to charge. So let's hook this thing up with our charging circuit. And now you can see we've got our 130 milliamps going into the phone. But here we see that the phone is actually not only using that power, it's still using power from the battery, which is like, well, wait a minute, we're supposed to be charging the thing, but you know, the screen is on, it uses a lot more power. Now, as the screen turns off, go ahead, go to sleep. Okay, now the screen is off and we can see we have a minus sign on our current flow, which means the current is actually going into the battery now. But looking at our charging circuit, we're still drawing 130 milliamps. So what's happening here? We've got 130 milliamps and only less than 30 of it is actually making it into the battery. So the phone itself is consuming over 100 milliamps. Almost most of what we're making is just getting used in the phone. Now, why would that be? Well, these lithium batteries are really impressive. We've seen this thing draw over an amp just by turning the phone on. It's pretty impressive what a little battery like this can do. But they are very sensitive to the voltage and current coming in and out of them. So every product that has a lithium battery in it has some kind of a circuit that its only job is to protect the battery. Make sure you don't use too much and make sure you don't overcharge it. And that's what's happening right now inside the phone is there's circuitry in here going, okay, just protecting that battery. I mean, sure, the CIA might be spying on you with it too, but mostly it's the battery that's being managed with all this circuitry in there. So this is why when I left the thing overnight here on the bench, it really didn't change the charge on the battery because so little of the power that was going into it is actually charging the battery. So this kind of sucks for what we're trying to do. Now, the good news is we already have everything we need to safely charge this battery right here. And we already have a way to connect to it now that we can just set our voltage and current properly to charge the battery and take the phone away, charge the battery. Once it's charged, put it back in the phone and we're good to go. Now, I charged this phone all the way up and measured the voltage on the battery. So when this battery is fully charged, it's at 4.3 volts and change. So as long as we set the voltage of our buck converter to 4.3 volts and just let the current do whatever it'll draw, we should be fine. It won't overcharge the battery that way and we can safely leave it there. So let's hook that up and try that. Okay, I've had this thing hooked up pretty much all day just to see what it would do, and it behaved kind of like you'd expect trying to charge a battery with a fixed voltage. And right at the beginning, it was running at the full 130 milliamps that we set the current to with our buck converter, and then very quickly that current started dropping off as we were getting closer and closer to that voltage that we were limited at. And that's just how it goes when you're trying to charge a battery that way. And it took us about, you can see, about 4 hours to get from 16%, so essentially a dead battery, to 50% charged. So way better than it was when it was inside the smartphone itself, relying on the smartphone charging circuit to fill it up. But a way better use, I think, is to do something like this, where this is a USB chargeable flashlight or a USB chargeable phone battery for charging your phone remotely. And this one even has a little solar panel in there that in a real pinch you could lay it out in the sun. It takes a very long time to charge. But either one of these if you don't want to mess with this whole, connecting directly to a battery, you just want to go back to the, hey, let's set this up for USB voltage and 130 milliamps. These are great options. I took both of them apart and tapped into the battery as I was charging it to see how much of that 130 milliamps is actually making it to the battery. And both of these are fantastic. The flashlight, and you can charge it with even 20 or 30 milliamps, and still most of it is going to go into that battery. But yeah, the flashlight, almost all of that 130 milliamps was going right into that 18650 size battery. Fantastic battery. And then same thing with the little solar chargeable unit here. Again, nearly all of the power was going right into the battery. So much better than that old smartphone. Now, this guy has the advantage that once it is fully charged, you can plug right into it and charge a smartphone directly, and it's not going to care about limited current. This thing will put out 500 milliamps, no problem, and charge any of the biggest smartphones, where if you were just trying to charge it with the USB on this thing, we already showed that some smartphones can't charge on that at all, and then even if it looks like they are, it's just a trickle amount, hardly making any progress. So that's a fantastic option for anything where you have super low power and you want to get to the point where you could charge a smartphone. I think for me, I'm going to go with this guy. It's waterproof, and say we're a smartphone that you want to be able to use every day. You don't want to have to wait. What is it going to take? Probably, let's see, 4 hours of runtime there. It's probably going to take an inch or two of rain before you can, just to get this battery halfway to full. So, even in a rainy month, that's going to be a week or two of pretty steady rain just to be able to make a phone call or browse the internet. It's really not a great application for something like that. Whereas a flashlight that you're only going to use maybe when the power goes out, or you have to go out in the shed or something, it's like, hey, I'll grab that flashlight real quick. That's a great thing to leave there and just let it charge as it has time to, and you use it for a bit and then it goes back on there and gets topped off again by the rain. And something like this with that 18650 battery in there, that's as much power as any of the larger smartphones. For that thing to charge up, you're probably talking 2 or 3 weeks of heavy rain to fully charge one of these. And it looks like the electronics that are in both of these are good enough that it's actually going to charge at a nice steady rate right up until the end, unlike this where you notice it charges really well at the beginning. These will actually do a constant current until you get almost completely charged, and it'll switch over to make sure it's not topping it off. So two fantastic options. I think the waterproof flashlight here is the one that I'm going to stick out there and keep plugged into this thing.
Okay, we have our charging station set back up where it's supposed to be, and we have our flashlight plugged in. The sucker is charging, but it's time to show you what this auxiliary switch is for, because I used to get really depressed when I saw that rain was coming, but now I kind of look forward to it, because when it rains enough, this little custom string of Christmas lights lights up on the front of my shop, and I think that's pretty cool.
A lot of people have asked, why don't you just put a solar panel on your roof? Wouldn't that be more efficient? But the answer is no. Solar panels actually have really low efficiency at 15 to 18%, whereas our water generator is more like 40%. The problem is we're using an entire roof to be able to make less than 1 watt, whereas this individual panel can make up to 50 watts. So yeah, while solar panels are really inefficient, for most of the world, solar energy is really plentiful. So they're a great solution to make clean power. Now we still have the question, is this a practical way to generate power at your house? And the answer is no. If you look at the labels on the appliances in your house, you're going to see they use anywhere from hundreds to thousands of watts of power. And this thing is never going to be able to produce that. but it is a great way to learn about engineering and science for anybody that wants to tackle it. Now, I was going to wrap this project up with part 4, but then you people got on the comments and started giving me all these other fantastic ideas of things that I haven't yet tried. You want to see Tesla turbines, you want to see the turbine encased somehow, and yeah, I guess I don't have a choice. I need to go do those things. I do have a lot of other projects that I want to tackle, especially as this rain is starting to taper off. But I promise I will tackle those things and I will keep making fantastic videos. What you can do in the meantime, if you want to help support that effort, check me out on Patreon to consider supporting the channel, and definitely like and subscribe, and that way I'll see you in the next video. Thanks for watching.